Have you ever hit a wall on a problem that just felt impossible? Well, in the world of math, there are equations just like that. Absolute monsters that have stumped some of the brightest minds for centuries. Today, we're going to look at one of these beasts and, even better, a brand new, totally revolutionary key that was built to unlock it perfectly. Okay, so here's our game plan. First, we're going to size up this mathematical monster. Then, we'll get into why the old ways of solving it just couldn't cut it. After that, we'll introduce the new secret weapon, see exactly how it works its magic, step by step, and finally reveal the answer it finds, which, trust me, is surprisingly cool. You know, every great story needs a great villain. Well, in our story, the villain is this massive, intimidating thing called a high-degree polynomial. And when I say high degree, well, you're about to see just what I mean. And here it is. Yeah, that's an 11th degree polynomial. It's a long, scary-looking equation where the goal is to find the one exact value of x that makes the whole thing equal 0. For centuries, this was a mathematician's nightmare. With so many parts and those huge powers, getting a perfect, clean answer was thought to be pretty much impossible. So how did people even try to tackle a monster like this? Well, for a long time, they had tools. But those tools had a major flaw. They could get you close to the answer, but they could never really guarantee you'd hit the bullseye. And this is where it gets really interesting. On the left, you've got the old guard, methods that are basically a series of super educated guesses. They inch closer and closer, but they can create tiny little rounding errors that mess everything up. But on the right, that's the new key. It's not about guessing. It's a structured process that's designed to give you the exact answer, not as a messy decimal, but as a clean, perfect number. No room for error at all. So if the old ways are kind of like fumbling around with a lockpick, what is this new perfect key? Well, it's a really powerful new idea in mathematics. It's called Ezouidi's theorem. And you can think of it like a special recipe cooked up for exactly this kind of supposedly unsolvable problem. Instead of estimating, it breaks the huge equation down into these smaller logical steps, using something called recursion, where each step just builds perfectly on the one that came right before it. And this shows you the ingredients that make the whole thing tick. It's using a specific mix of components in a really smart way. You've got things like binomial coefficients, which are just these special numbers that help wrangle all the terms, and they're combined with numbers from the original equation. Each one of these parts is like a unique cut on a key, designed to fit the lock of this polynomial perfectly. All right, now let's actually watch this key in action. The theorem works by running through a series of calculations, and the whole point is to see if a very specific thing happens every single time. If it does, that means the lock is about to open.
And this is where it gets kind of amazing. The process starts, first step, and the result is a perfect 0. Okay, cool. Then it does the second step, and the result is 0 again. The third step, it's 0. The fourth, also 0. This keeps happening for 10 different complicated calculations, and every single time, the answer is a clean, undeniable 0. Now that is not a coincidence. That's the theorem proving, step by step, that it's on the right track. It's like hearing every tumbler in a super complex lock just click perfectly into place, one after another. So after all those steps line up just right, that final tumbler falls into place. The lock clicks open. So what is it? After all that complexity, what is the exact, perfect answer that was hiding inside this mathematical beast? It's 1. Just 1. That whole ridiculously intimidating equation, with all its giant numbers and powers, it all boils down to the simple number 1. That is the exact root. But wait, there's one last really elegant twist. The answer isn't just 1. It's 1 with what's called a multiplicity of 11. So what on earth does that mean? Well, to put it simply, it means the root 1 is so deeply fundamental to this equation that it's almost like the answer is 1, 11 times over. It's literally baked into the equation's DNA, which is exactly why a precise tool like Ezouidi's theorem could find it so cleanly, where all the old guessing methods would have just gotten lost. And that right there brings us to a really cool final thought. This was never just about solving one hard math problem. It was about proving that a new way of thinking, a new key, can open doors that we thought were sealed shut forever. And it really makes you wonder, right? What other problems in math or anywhere else aren't actually unsolvable? They're just waiting for somebody to come along and invent the right key.